Okay, in the previous class we have solved one problem on packed bed, right, using Ergun's equation. What did we do? We assumed a value of delta P, and from the Ergun's equation because from that delta P we found out the exit pressure, and from that average air density between the inlet and outlet. So, that average air density we utilized, and we got the assumed and actually calculated values were very close, right. And we said that if possible in future we will also try to do similar problems, or if we come across another problem, then we can practice and utilize the Ergun's equation more meaningfully, right. So, let us do another problem. This is like this: air at 390 Kelvin flows through a packed bed of cylinders having diameter of 0.0127 meter and length the same as diameter. This means the cylinder can be treated as a sphere. The bed void fraction is 0.45 and the length of the packed bed is 4 meter. The air enters the bed at 2.5 atmosphere absolute at the rate of 3 kg per meter square second, right. So, mass flux is said based on the empty cross section of the bed. Calculate the pressure drop of air in the bed given molecular weight is 29 and mu 1.5 10 to the minus 5 Pascal second, right. So, I repeat, this is like that: air at 390 Kelvin flows through a packed bed of cylinders having a diameter of 0.0127 meter and length the same as diameter. That this means that the cylinder can be treated as sphere. The bed void fraction is 0.45 and the length of the packed bed is 4 meter. Air enters the bed at 2.5 atmosphere absolute at the rate of 3 kg per meter square second based on the empty cross section of the bed. Calculate the pressure drop of air in the bed given molecular weight of air is 29 and viscosity of air is 1.5 10 to the minus 5 Pascal second, right. So, if you solve this, what is said that we have a packed bed of cylinders. Now, these cylinders do have, this is the cylinder height, right. So, height is equals to the diameter, that is why this can be taken as d and this is d. So, these two d's are same. So, the cylinder can be assumed to be sphere, right. But if we assume a cylinder to be a sphere, then all cylinders can be equal to sphere. So, then it appears that you may have to find out the sphericity, how close it is to a sphere, right. So, that we will find out. First, you have to find out that here, as we have said, that if this is a cylinder, right, if this is a cylinder, if this height and this diameter, if this height and this diameter are same, then it theoretically diameter and height of a cylinder, if they are same, then that appears to be equal to a sphere, right. But whether it is a sphere or not, or what is the sphericity of that sphere, right. Sphericity means how close it is to the sphere, that first you have to find out, right, and then you can use the other things, right. So, let us find out that the length of the cylinder that is L is equals to diameter of the cylinder, say D cylinder, right. Therefore, volume of the cylinder V cylinder, that should be equals to pi by 4 into D of cylinder, right, square into D of cylinder, which is the height, right. That means pi by 4 dc cube, right. So, this should be equals to pi by 6 dp cube, that is the actual volume of the sphere having particle diameter dp, right. So, our given thing was the cylinder has a diameter of D cylinder is equals to 0.0127 meter, right. So, if that be true, then dp cube is equals to this pi goes off. So, 6 by 4 dc cube, right, or dp is equals to cube root of 6 by 4 dc cube is equals to cube root of 6 by 4 dc is 0.0127 so much cube, right. So, let us look into what the value is. So, 0.0127 cube x to the power y or x is cube, right. So, this is that into 6 divided by 4, right. So, is cube root, right. Cube root is 0.0145 is equals to 0.0145, right. So, that means particle diameter is 0.0145 meter, right. Then we can say that phi s is 6 Vp by dp sp. This we have done in the packed bed class beginning, right? Phi s is 6 Bp by dPsP, right, is equals to 6 into pi by 4, Vp is pi by 4 dc cube, right, divided by dP we have already found out to be, say, this is the value, but this we can also write to be cube root of 3 by 2 into dc cube, right. So we can also write this to be cube root of 3 by 2 dc cube. No, dP is dc cube root, so it is dc, not cube root of this, right. Perhaps here dP cube is 6 by 4 dc cube, right. So dP is cube root of, okay, dc cube is that 6 by 4 dc, right. So cube root, if it goes out, so it is 3 root 3 by 2 dc, right. Better we write this way, cube root 3 by 2 dc, because this dc cube root it goes out. Okay, so dP is so much, and sp, this into sp is how much? It is pi dc square, right. 3 by 2 pi dc square, right. Sp is 3 by 2 pi dc square, right. So this becomes equals to, this is dc cube, so this is square, so this goes out, right. This pi goes out, right, and this is 6 pi by 4, there is 6 by 4, that is 3 by 2, so this 3 by 2, this goes out, right. So then it remains 3 by 2 under root 3, right, 3 by 2 under root 3. Three divided by 2 is equal to so much, cube root of that, no, this becomes cube root of 3 by 2, okay, dc into 3 by 2 now pi by sp is pi dc square, okay. So it is pi dc square, so this 3 by 2 may not be going out, so 6 by 4, so it becomes 3 by 2, okay, because sp is how much? Pi dc square, so where from this 3 by 2 comes? So then this dc cube goes out, then 3 by 2 and this divided by under root 3 by 2 under cube root. So it is 1.5 divided by that came to be 1.14. Six BP. BP is pi by 4 DC cube. Fine. And dP is from there cube root of 3 by 2 dc, cube root of 3 by 2 dc. Fine. And this is pi dc square, that is the SP, that is the surface area of this particle, that is pi dc square. Right. So pi goes up, 6 by 4 remains, 3 by 2 by root 3 cube root of 3 by 2. So this is 3 by 2 1.4. So 3 by 2 cube root is 3 by 2 cube root is 3 by 2 is cube root is 1.144. So 1 by 1.5 by 1.144, 1 divided by 1.5. No. I think I am making a mistake. That is 3 by 2 1.5, 1.5 cube root of this, inverse of this. Yes. So it was 3 by 2 is there. Then it becomes equals to, right, this 3 by 2 goes off, 1 by cube root of 3 by 2, right. So that becomes equals to 0.873, right. So phi s is 0.873. Then if phi s is 0.873, then we can write NRE, right. NRE is equals to phi s by mu to dP, right, into G prime by 1 minus epsilon. So this becomes equals to phi s is 0.873, dP is dP we have found out to be phi s, dP we have found out to be that cube root of this, no? Okay. So that if we put dP, dP not given, dP we have to find out, that is 6 by 4.127 cube. So that goes out dc, that is cube root of 3 by 2 dc, right. So cube root of 3 by 2 dc, dc we have been given that. So it came to be 0.0145, 0.0145, right. And G prime is it given? G prime is given as 3 kg per meter square into 3 divided by mu given is 1.5 10 to the minus 5, right, and epsilon given is 1 minus 0.45, right. So this becomes equal to 0.0127 is given. Oh, the cylinders having a diameter of 0.0127. Yes, that dp is given, no, 0.0127. So not required. It is 0.0127, right? So this is 3. So we can write that 0.873 into 0.0127 into 3 divided by this divided by 1.5 this divided by 1 minus 0.45, right? Divided by 10 to the minus 5. (4031), right? So that means that our NRE is very, very high, right? So in the outlet pressure depends on delta P, right? So we assuming as first approximation density is equal to that at the inlet pressure, right? So inlet pressure given is 2.5 atmosphere, right? So rho inlet is equals to Pm by RT, or P inlet by RT is equals to 2.5 atmosphere 1.01325 10 to the power 5. M is 29, R is 8314, and T is given 390, right? T given is 390. So it comes to be 2.26 kg per meter cube, right? Now from Ergum's equation, we have seen that delta P rho by G prime square, right, phi s dP by delta L epsilon cube 1 minus epsilon 150 by NRE plus 1.75, right? So from this we can write that delta P to be equals to G prime square, right, by rho into delta L by phi s ds, phi s dP, 1 minus epsilon by epsilon cube, right, into 150 by NRE plus 1.75. right? So this, if we write, that means this is 3 squared by rho. Rho we found out 2.266, right? Delta L given is 4. Delta L given is 4 meter. Here it is 4 meter. So 4 by 5 we have found out 0.87, sorry. 5 we have found out 0.874 or 3, right? Say 0.873 we have found out, or say 4. 3 something was there, so rounded off to 0.874, right? So delta P, so 1 minus this has been given as 0.45, 0.45, right, divided by 0.45 cube, right, into epsilon 150 by NRE. 150 by NRE. NRE is 4036 plus 1.75. This is equals to 15.439 kilopascal, right? So delta P is 15.39 kilopascal. Therefore, since P inlet is equals to 2.5 into 1.101, 1.01325 10 to the power 5 Pascal, right? There, and delta P is 15.439 Pascal, right? So therefore, P exit or outlet is equals to 2.5 into 1.01325 10 to the power 5 minus 15.439 Pascal. This is also Pascal, right? So this means that delta P comes to be equals to or P outlet comes to 268.7515 kilopascal, right? Now with this outlet as again 1, so then, and this is P inlet, so P average can be found out as P inlet plus P outlet over 2 is equals to, this comes to be 261.032 kilopascal, right? Therefore, rho average, that can be written as P average M by RT, and that can be seen to be equals to 2.34 or 334, rather 334 kg per meter cube, right? And if we do the same way delta P calculation, then delta P comes to be 14.589 kilopascal, which is very close to the assumed value, or what we have found out P average, right, from there. I'll do first approximation, right? So very close to the delta P assumed. So we can say delta P to be equals to 15.069 kPa finally, right? So this way, by doing trial and error, you can find out that what is the exactly delta P, or if one is given P1, you can also find out the outlet, whatever given depending on the situation. So where you have seen that we have taken both the laminar part, turbulent part, that is the entire Ergun's equation, and from there if one is given, like inlet pressure is given, outlet is not given, and right in this case we assume that both inlet outlet or they are different, true, but we assume that the density to be at the inlet pressure, and we found out delta P. With that delta P we found out the pressure outlet, and from there again averaged, and from that average again we found out what is the delta P, right. So, this way by trial error you can find out the actual value. Okay. Thank you.